Okay, on the previous class, we have already looked into what happens to the characteristics of the image apabila objek diletakkan lebih jauh daripada 2f dan juga apabila objek diletakkan pada kedudukan 2f. So for today, I hope you guys have looked on how to draw for all the rest 3 images, but let's go through together. Untuk case seterusnya, kita akan letak objek. Objek adalah di antara 2f dan f ya. Objek diletakkan di antara 2f dan f. So let's say your object is placed at here between the f and the 2f here. So let's draw the first ray diagram. Yang ray diagram pertama menyatakan light ray parallel to principal axis. Okay, sinar cahaya yang selari dengan paksi utama akan dibiaskan melalui titik f. So we're going to have a light ray passing through the f point here. Okay, on the next note here, we also have another rule says a light ray passing through the f point. Okay, so I'm going to use a different color here. A light ray passing through the f point. So from the object, it's going to pass through the f point. And once you have passed through of f point, then the light ray is refracted parallel to principal axis. So I can see some meeting point here at this point here. And this is where the image is formed. Remember, anything forming behind a lens is a real image. So kita gunakan garis biasa, and that's where your image is formed here. Now, let's look on the characteristics of the image formed here, class. So in that case, if you look, firstly, the object is become bigger, magnified. If you look on the small object, and here, the object becomes magnified, first of all. Okay, next, what happens here next is, how about the is it a real virtual? Since it's forming behind, it's going to be a real image. Okay, and the last one here, it is also an inverted image. Dia adalah songsang. So we are done on the drawing when the object is placed between f and 2f. Let's move further. When the object is placed exactly at a f point, so kali ini kita akan letakkan objek pada kedudukan F ya. Jadi objek pada kedudukan F. So what happens here? So we use the same concept here ya. Rule number 1. A light ray parallel to principal axis is refracted passing through the F point. So it's going to be refracted passing through the F point. And here I can't use the rule which is passing through the F point. Yeah. So I'm going to use the rule 3. The rule 3 or rule 1 in my previous says anything passing through the optical center, anything melalui titik pusat akan dibiaskan secara garis lurus. So I'm going to use that. So we have another one more line here before and after. And if I extend these two lines here, what's going to happen? The image is formed in front of the lens, but again you're forming a two line which is going to be exactly parallel to each other. Yeah. So the image might be somewhere here. The image might be somewhere here. Let me draw it here. We don't know where is it. Okay, it's going to be in an infinity position, but it's exactly going to be in front of the lens. So first of all, in that case, what we can say here is we're going to form a parallel lines. Okay, parallel lines is formed. So first point here is parallel lines formed. Secondly, the image is formed at infinity. We are not so sure where does the image going to exactly formed at infinity. But even though it's formed at infinity, it's going to be upright somewhere in front of the lens itself. Anything forming in front of a lens, if an image terbentuk di depan kantor ya, maksud dia adalah virtual. We already looked into it previously. So that's exactly going to be virtual. And also what going to happen here, it's going to be magnified sebab dia kena besar tapi dia dalam keadaan infinity. So magnified. So we are done for the drawing U equals to F, and let's move to the last drawing, which is the object is placed less than F. So kali ni objek ni akan letakkan lebih kurang daripada F. So let's say that's the position of your object now. So let's look what are the characteristics. I'm going to use rule number 1 again. A light ray parallel to principal axis is refracted passing through F point. So it's refracted passing through F point. And another rule says a light ray passing through the optical center melalui titik pusat akan dibiaskan dalam garis lurus. So if I'm going to extend this line here, I can imagine able to extend this line here, class. So let's say I'm extending. At the same time, this blue line can be also extended. Okay, so imagine this is also being extended. And what happens here, I'm going to see somewhere at behind, in front of the lens, there is an intersection point. Remember, anything in front of lens is a virtual. We label a virtual image with a dotted line. So that's your image being formed here. So apa ciri-ciri image yang terbentuk kali ini? So if you write down, it is formed in front, it's magnified first of all. It is magnified. Okay, it is magnified. Secondly, what going to happen to the size of the image? Okay, what happens to the size of the image magnified? It's also a real image. Okay, sorry, it's a virtual image. It's a virtual image because it's forming in front of the lens. And the last one here, it is exactly going to be an upright. Dia tegak, yeah? It's an upright image. So there we go. We are done with the characteristics for all the different positions of an object, which is going to be u more less than 2f, u equals to f, and u between f and 2f, and u equals to f, and so on. One correction here which we have wrongly drawn here, yeah? This is not magnified. Okay, that's because of the drawing, it looks as though magnified, but indeed if we redraw back again, this will be a smaller image. Okay, image that is formed going to be smaller. Yeah, so please cancel out this. This is supposed to be a smaller image, or the image is diminished. Okay, now let's look into another type of lens, which is also another curved lens, iaitu kanta cekung ataupun concave lens. Yeah, so the shape wise, what going to happen here, it's as though two mirrors facing opposite of each other. So that's how it looks like, and then we combine them together. That's the shape looks like. And remember what happens in concave lens. As the light rays, so let's say we have a principal axis here, as light rays are approaching towards this lens here, all these light rays here will be refracted as though diverging out from one point. It's all going to be as though diverging out from one point. Okay, and the diverging point here is called as let's say here also we're going to as though have all the lights diverging out, dia mencapai keluar, ya, dan titik di mana dia mencapai keluar ni, seolah-olah mencapai keluar ni adalah titik fokus. Okay, now let's go and look on the rules that related to this lens here. Rule yang pertama menyatakan bahawa sinar yang melalui titik pusat ni sama macam kanta yang sebelum ni, ya, similar like your convex lens. Okay, so what going to happen here, light ray which is passing through the optical center will not be refracted in any direction. It's going to move in a straight line. Okay, and the second rule says a light ray which is parallel to principal axis, sinar cahaya yang selari dengan paksi utama akan dibiaskan seolah-olah keluar daripada titik F, refracted away from F point. So it's going to be dotted point here and then refracted away from the F point. And rule number 3 says sinar cahaya yang seolah-olah diarahkan ke arah F, if the light ray is as though pointed towards F, and therefore this light ray here will be refracted parallel to principal axis. So these are the 3 rules that is related to the lens that we are learning now. Okay, now by using these 3 rules here, let's draw a ray diagram. Okay, let's draw a ray diagram for this. So for that, let's look on how does a ray diagram look like. So for that, I have placed the object at between F and 2F. But remember, for this type of a concave lens, mana-mana posisi objek, ciri image dia tetap sama, ya. Ciri image tidak akan berubah. The characteristics of the image will remain the same. It's not going to change wherever you position the object here. But let's just draw for one and see what is the characteristics of the image. So the first one here, I'm going to use rule where it says light ray parallel to principal axis. A light ray parallel to principal axis is refracted as though moving away from F point. So I'm going to draw it as though moving away from F point. And I'm going to use the rule number 1 which says a light ray which is directed towards the center of the optic center, the center of the sphere, okay, will not be refracted or will be refracted in a straight line here. So it's going to move in a straight line. So therefore, I can find some point here, intersection point here. This is where the image is being formed here. Jadi apa ciri image dia? The image is formed in front of the screen. So we know anything forming in front of screen is going to be a virtual image. It's a virtual image. Next, if you compare the size becomes smaller. So it becomes diminished. Okay, diminished. And the last one here, it's going to be an upright. Dia tegak ya, so upright image. So this will be the characteristics of the image form when the object is using a search lens. But remember, this image characteristics remain same, tetap sama walau mana pun tempat posisi objek dia, whether I position it here or anywhere, wherever you position it, the characteristics here going to be the same, where the characteristics still is going to be virtual, upright and diminished. So we have already done covering every single section of this subtopic of lenses. We have looked on the power with the two formulas, and then we have moved into convex lens rules, and then we have looked on all the characteristics here, and the last one we have gone into the concave lens, and we have looked on the rules and also the characteristics of the image form. The next class will be looking at use of these lenses, okay, combination of these lenses either in a telescope or a compound microscope. See you.